Good morning, everyone. We are going to look at 7.1 today. I kind of always like to start this chapter looking at a basic problem. So two types of allowance situations. Your parents offer to give you $20 a week for 20 weeks, or you say, you know what, just give me a penny the first week, give me 2 pennies the second week, 4 the third, 8 the fourth, et cetera, et cetera, et cetera, for 20 weeks. Which is the better deal? At this point in your math careers, you probably know that the better deal is, starting with a penny and doubling it each week. If we take a look at things, the most you're going to get each week with the $20 a week is going to be $20, okay? When we look at the penny, if we start with a penny and we're going to double it every week for 20 weeks, think about how many times we're going to end up doubling it. We're going to double it 19 times, all right? Because we started at a penny, we doubled it, doubled it, doubled it, doubled it, doubled it. It's going to take 19 doubles to get to our 20th week. So if I figure this out on my own or in my calculator, or you can do it recursively and multiply a penny times 2 and do that 19 times, you're going to get $5,242.88 that 20th week. Okay, so this kind of displays the power of exponential growth and why it's so important in math. It relates a lot to your finances if you're looking to invest money in the future, whether it be for college or retirement. Compound interest is a huge thing, and we'll look at that in a little bit, as well as just population growth. If you go into medical research, watching, bacterial populations grow, how to slow that growth, how to change the growth. If you go into science, looking at carbon-14 dating, exponential decay, all that stuff. So today we're just going to kind of explore graphing exponential functions. Very straightforward. We're going to see h and k again. I'll kind of zoom in here for you a smidge. But you're going to see problems like this. This is probably one of the more complicated or involved, just because there's an h of k and an a value all in this problem. So what we're going to do, easiest thing to do, you guys, just make a table. Okay, so this is something we haven't graphed before. We're going to make a table. What I always like to do with exponential functions is look at the power, and I see that 3 there. All right, so I'm going to start my table at -3. I'm going to try and figure out a place where that starts at 0. So I'm going to -3 plus 3 is 0. Then I'm going to do one number to the left, one number to the right, and that's as simple as things go from there. So if I plug in -3, we're trying to figure out the y value. -3 plus 3 is 0. 2 to the 0 is 1. 1 times a half is a half. -4 is -3.5, or -7 halves. All right. Grab the next number. -2 plus 3 is 1. 2 to the first is 2 times a half is 1. 1 minus 4 is -3. If I plug in a 4, -4 rather, -4 plus 3 is -1. Okay, reminder, when we have negative exponents, that flips. So 2 to the -1 is going to be 1/2. 1/2 times 1/2 is 1/4. 1/4 minus 4 is -3 3/4. -3 3/4, if I want to write it as a improper fraction, is going to be -15/4. All right. So from here, all we want to do is graph. So I'm going to zoom out a smidge so you can actually see. With these graphs here, when I plot these points, I'll actually use green here. -3, -3.5 is going to be right about here. -2, -3 is about here. -4, it's almost going to be down at -4. So if you notice, this graph kind of goes like that. Exponential growth. Okay. One thing we do want to point out with exponential growth curves is there is always going to be a horizontal asymptote. Okay. And if you look at our graph, where is it kind of leveling off to? It's leveling off to y equals -4. Coincidentally, that is also our k value in the problem. All right. So this is kind of a summary of exponential functions. You can see below, h again is that left and right movement. K is that up and down movement. A is going to be the orientation and shape. If A is positive, we're going to growth up. If it's decay, it's going to flip and go down. Okay, so you can pause the video if you want, kind of take a look at this chart, write it in your notes if you need. This goes for both growth and decay functions. The only difference would be your b value is a number greater than 1 for growth. Your b value, or the base of that power, is going to be a fraction between 0 and 1 if it's decay. And we'll look at that next. Back, quick overview of things. Again, when you're graphing, biggest thing, pick x values that make it nice for you. All right, so the easiest thing to do is look at that power, look at your h value, figure out what makes it 0, put that in the middle, take 1 to the left of that, 1 to the right of that, and you'll be golden on those. Okay, looking at here, h is our left and right movement of our graph, k is our up and down, a is that orientation and shape. Again, we're always going to have an asymptote at our k value on these graphs, whether it's growth or decay. As we're looking this over, I noticed I forgot to state the domain and range on this question, so I just want to go back to this quick. When I look at our graph and I'm looking at the domain, well, my graph goes left and right forever. So just like with all exponential graphs, our domain is going to be all reals. And like I said before, we have an asymptote at our k value. So in this case, if I'm looking at my graph, I don't have y's that go on forever. They only go down to -4. The question is, what's the sign? Well, it's greater than -4 because it's never actually going to get there. And you can see that from our table, actually, as the values get closer and closer to -4. They're never actually going to get there. They're going to get fractionally closer. All right. All right. Looking here, we have a problem based on exponential growth. All right, your parents, or grandparents rather, are super awesome, and they decided to give you $5,000 to put into your college fund. Typically, if they invest it wisely, 9% is pretty attainable as far as growth goes over the long haul. You want to see how much money you will have in the fund when you get to 18 years. Okay? So, when we're looking at this problem, 9% annual growth. All right? So, we're going to start with our basic simple equation. Okay? So, our simple equation, our final amount is always going to be our principal, and it's 1, and I'm just going to put in plus or minus r to the t. Okay? The reason I'm going to put plus or minus r is if we're increasing in this exponential growth, we're going to add our rate. If we're losing value or depreciating, we're going to subtract our rate. But this is the model you're going to use for all of your word questions problem in the homework tonight. All right? So keep that in mind moving forward. So in this problem, our principal amount is going to be $5,000. That's what our grandparents gave us to invest. We're investing at an annual rate of 9%. Okay? The one thing to keep in mind, when you're always given it as a percent, it needs to go in your equation as a decimal. Okay? And then your power is going to be 18. All right, so if we take this after we plugged everything in, obviously you probably want to go to your calculators, but you're going to have 5,000 times 1.09 to the 18th. And check this out. Hit enter, you're going to see you're going to have $23,585.60. So how about that, grandparents? Nice job. All right, you almost quintupled your money, if that's even a word. So really, really, really powerful in terms of things is this idea of exponential growth. At the same merit, we have the idea of exponential decay. Like I said before, if you're going to have a decay model, you're going to be looking for a B value or a base of your power that's between 0 and 1. All right, so that's how you can tell the difference between growth and decay is just the base. If it's a fraction between 0 and 1, it's decay. If it's a number bigger than 1, it's going to be some sort of growth model. So we're just going to put this to use in a word problem here. You can see my Maserati here. Totally sweet, totally affordable on my teacher's salary. I just bought one, 2019 Maserati. 107.4 was the base price. I put some extras in it, but I'm not going to tell you how much I spent on those. But Consumer Reports estimates that car values lose 14% of their value each year. All right, so cars, not a good investment. Homes, good investments. Okay. When I want to get a new car in 2022, what will the value of my car be? What am I going to get for my trade-in, essentially? All right, and so we do the same idea as before. We're using the model up above. Okay, so my principal, again, in this case, is $107,400. In this situation, since I'm losing value on my car, I'm going to subtract my rate. And from 2019 to 2022, that is 3 years. So when we plug this in, again, we're looking at 107,400. 1 minus 0.14 is going to be 0.86. I'm left with essentially 86% of the value of my car each year I own it. I'm going to own it for 3 years until I want to trade it in and get a new one. When we type this in, this is absolutely the most depressing thing in the world. My car value that was 6 figures is now valued at $68,312.41. Totally not cool in terms of things. But that's kind of the idea of exponential growth and decay. Moving on, just kind of an overview again. This is the model you're going to use today. All right. It's your principal amount times 1 plus or minus your rate, depending on growth or decay. And T is always going to be your time in years, okay, for the most part. I don't think many questions actually go down to like minutes or seconds or anything. So T should be your time in years. If the problem switches to, you have 9% growth each minute, well then T would be the number of minutes that passed. Okay, so just something to keep in mind. Decay, like we did on example 3, instead of adding our rate, we subtracted our rate. Real world lesson from example 3, cars, bad investment. Homes would be a good investment. All right. Homework's at the bottom of the page. We do have a worksheet as well that's available on Schoology if you're not in class. Best of luck on this assignment, and let me know if you have any questions.